Okay, so we have this idea that the integral of a derivative is equal to an original function plus c. Now, I'm going to try to explain what c means. But the big overarching picture that I need you guys to understand is that integration is the inverse of differentiation. Now, remember, integration is that idea of taking the antiderivative, the opposite of the derivative, the original function, okay? So, for example, I'm going to have, let's say I have the integral of x, okay, dx. This is telling me that this is a derivative, right? Okay, so what I want to know is where could this x come from? Okay, where could that x come from? Now, the big idea is that whatever function I had originally gave me this derivative. So I want you to think about what would give me an x as a derivative. Okay, the only way I can get an x is if I had something like an x squared, right? So if I had an x, or I have an x in my derivative, that means I needed an x squared in my original function. Okay, but, there's the big but here. Okay, if I took the derivative of x squared right now, I would get 2x. Is that what I have? No, that's not what I have. I have x. So what do I have to multiply by 2 to get this coefficient, this invisible coefficient? That's a 1 over here. 1/2. Okay. Yes, indeed. So I have 2 times 1/2 is 1, which is what I need. Okay, so that's my original function. Now, we also have to remember, the derivative of a constant is what? 0. We could think about that there's also an invisible plus 0 over here. Okay, we could think about that, right? Now that means that I have to have plus constant over here. That's where that plus c comes from. That's up here. We have to take into account that we always have a plus c going on here. Okay? Now I'm going to take a second to draw this original function over here, and then we're going to talk about it in a second. Okay, now we're back. I drew that graph in the intermediate. Now, what I have here is f of x. So that is actually 1/2 x squared. Now, the idea of the plus c is that I'm doing a vertical and horizontal shift. So if I had, like, let's say c equals 2, right? So that would move every point that I have up 2, right? So I'll go up 2, I'd go up 2, I'd go up 2. Oh, that's like 1. I'll go up 2. I'm so close to it that I'm not feeling like I'm getting correct. Alright. So now I have c is 2. So this would be 1/2 x squared plus 2. Now, its derivative is still x, right? So every point that there would be a horizontal tangent line of both of these would be exactly the same. I know that I really botched that picture. But that's the idea that we're going for with the plus c, is that we're going to be shifting this graph up and down, right? So I go up and I go down. All of these derivatives are still exactly the same, okay? Which is why we have to have this plus c attached. That's why you have to have these plus c attached when we do these derivatives.